Hi students. In this lecture, I am going to discuss problems based on above concepts. See first one. So what is given? A spherical body of radius r consists of a fluid of constant density and is in equilibrium under its own gravity. If P of r is a pressure at r, given r is less than r, it means it is inside the body. Then correct options. Okay. This is given 2015 advance. So we have to find out pressure inside the sphere. Okay. See what it means. Right. Let us make a diagram first of all. It is one solid sphere. You just imagine one shell of radius is smaller. Its thickness equal to dr. Okay. If you observe on this shell, weight of this top layer is acting. I am repeating, on this shell, weight of the top layer is acting normally inwards. That means there is no pressure because of this gravitational force. Okay. Or we can say that if we are going inside the earth, if depth is more, pressure will be more. If depth is more, pressure will be more. Okay. So if you are taking any one layer, you can see, suppose you are taking a point at a distance r from center of earth and at a distance r plus dr. We can see at this point pressure will be P, which is more, and at this point take it as P plus dP. I am taking now in the direction of increasing R. Okay, when R value increasing, I am taking this is now at a distance R. This is now when distance is R plus dr. And just now we have discussed that when depth is increasing, pressure will increase because having more weight on that layer. Or if you say from center, if you are moving towards surface, pressure will decrease. That means in this, dP itself will be negative. Okay, dP is now negative. Now see how we calculate that. Now take a diagram separately for that spherical shell which we are focusing. So this is now spherical shell which we are focusing in the sphere. Okay, let us now consider a small part on the shell, small part. And for the small part, area is now ds, okay, for a small part. And if you see from here, pressure P, and from here, P plus dP, okay, net value. Net value will be now, it is actually outwards because P value is more. I am saying it is dP value is negative. So net will be outwards. Therefore, now this net force must be balanced by gravitational force. If gravitational force acting on that element is balancing the force due to this pressure, then that element will be in equilibrium. Okay. Now see what we are writing here. Okay. I'm taking here minus dP. Why minus dP means dP value itself is negative, negative of negative positive. Minus dP into this area ds. That area ds, that gives us a force. and this force should be balanced by gravitational force. Let us take now, this is now at a distance r. Okay. At a distance r inside solid sphere, gravitational strength is Gm by r cube into r. That is now G value. Okay. Into it's a mass. Mass how much? Mass of that element. So I am writing here mass of that element means I will write here density m by 4 by 3 pi r cube density. Density into density into its volume. Its volume will be dr into ds. Okay. ds is now its area. Dr is now thickness. So area into thickness gives volume. Okay. And anyhow ds and ds gets cancelled both sides. Now take integration for remaining part to get pressure. So minus dp equal to gm square and 3 here and 4 is there. 4 pi r power 6. Remaining is now r dr. I am taking integration now. Integrate now r dr. Limits from we want to find pressure now at a point means distances are okay. So limits from if you are taking it is r corresponding value p. If you take capital R on surface there is no pressure okay. On surface there is no pressure. And as we are going inside, P value increasing because of the weight of the layers. So 0 when it is a capital R. Okay. Now see what we get here. 0 minus, already having here minus it. 0 minus P, taking minus okay, outside. That is equal to 3 gm square upon 4 pi r power 6. Remaining is now, integration is now r square by 2. R square by 2. I am taking 2 outside, 1 by 2. Remaining is r square minus r square. Okay. Now see what we get. Minus of minus to plus. So P equal to, in this focus now, here all values are constants only. I am taking as a K into r square minus r square. Okay. This is a relation we got for pressure as a function of R. Now we have to substitute values in that. You can see options now there. So given like one option, R equal to 0, pressure is now 0. Check once. If you take R 0, pressure is not 0. So this is not correct. Okay. And if you see second option, given pressure when R equal to 3R by 4 and pressure when R equal to 2R by 3. Then see how much we got. Ratio K gets cancelled. Remaining R square minus. This is now 9 minus 16. So 1 minus 9 by 16. 1 minus 4 by 9. See how much we got. 16 minus 9, 7. 7 by 16. And this is now 9 by 9 minus 4, 5. So it is now 63 by 80. Okay. So option B is correct. Next. See next option. Pressure, coming to third option, pressure. When R equal to 3r by 5 and r equal to 2r by 5. Okay. So how much we get? 1 minus 9 by 25. 1 minus 4 by 25. 25 minus 9, 16. 16. 16. And this is now 25 minus 4, 21. So option C also correct. And next we can say option D, right? Option D also we can verify. So let us verify option D also. Option D. P value when r equal to r by 2 and P value when r is r by 3. Okay. So 1 minus 1 by 4. Okay. This is 1 minus 1 by 9. So 3 by 4 into 9 minus 1, 8. It is now 8 by 9. So 27 by 32. And that is not correct, right? The given option given different value. So it is not correct, right? Okay. See next one. Three particles each of mass m are situated at the vertices of an equilateral triangle of side length A. The only forces acting on the particles are their mutual gravitational forces. It is desired that each particle moves in a circle while maintaining the original mutual separation A. Find initial velocity that should be given to each particle and also time period of circular motion. This is a question given in 1998 for 5 marks. See how to solve it. In fact, we have solved, I think, same kind of question earlier, right? Let us see once again. Given three particles, separation equal to A, separation equal to A. If you focus any one particle, force by remaining two will be gm square by a square. Resultant angle is now 60. It is now root 3. This is now resultant of those two attractive forces, which provides centripetal force, that is m into v square by r, and r value r equal to 2/3 of root 3 by 2a. Okay, already we have solved this question in previous lectures. A by root 3. Now substitute here a by root 3. Root 3 gets cancelled, and one mass gets cancelled here, and one a also gets cancelled. So v equal to root of gm by a. And since the speed is a constant, time period we can write as distance traveled is 2 pi r by speed v. It is a 2 pi r value a by root 3. V value root of it is gm by a, right? That is now 2 pi. Take a instead, it becomes a cube. It becomes now 3gm. Okay. So directly we can get the answer, very simple one. Right. See next problem. Right. A large spherical mass capillum is fixed at one position and two identical masses are kept on a line passing through the center of capillum The point masses are connected by a rigid massless rod of length L, and this assembly is free to move along the line connecting them. All three masses interact only through their mutual gravitational interaction. When the point mass needed to capital M is at a distance r equal to 3L from M, the tension in the rod is 0 for M equal to. If you see carefully, tension in the rod is 0 means the only possibility is now this is attracting this one left side. This also attracting this one, that is right side. If these two are balanced, net force becomes 0 because tension given 0. I am repeating. This bigger one attracting this one left side. This smaller one attracting right side. If these two are balanced, then net force becomes 0 because tension is 0. Next, in the same way, this is now attracting this one left side, right? And this also attract now this one, it is left side, right? See carefully. This is attracting left side. Now, this also attracting, it is now left side. So net force must be equal to sum of those two forces because there is no tension, right? That means, see what we can write now. First of all, draw a diagram for this one. It is now bigger mass, smaller one, and this also smaller one. And we are given now separation. This is 3L from center, and we are given remaining is length is L and this is L. And say condition tension is 0. Tension 0 means one thing. I think here force by this on this, force by this on this should not cancel. Okay. What we can say is now it is just a rod to the ends of the rod connecting two masses. Connecting two masses. On this one, attraction right side, attraction left side. And if you observe, on this one, attraction is only left side. Net is not 0. Sorry, it is not net force, not 0. What we can say is acceleration must be same for both. Acceleration must be same for both. Okay. Then see what we can write. Net force. Net force on this equal to net force on that is equal to G M1 M2 by separation is now 3L. So square of 3L minus y minus means this attracts. This attracts. This attracts. Right. Take diagram once again. So taking the bigger sphere and taking these 2 point masses here, M and M, M and M. This distance equal to 3L and this is so force by this on this. That is now left side, and by this it is the right side. So net value will be G m1 m2 by r square 3l whole square. Okay, 3l whole square minus G m1 m2 by L square. This is now net force, which is equal to mass into acceleration. Okay. Now for this also net force must be equal to same. That means that is equal to force acting on this by bigger one, attraction. And this also attraction only, both are in the same direction. Okay. So we have got a G m1 m2 by 4L whole square plus G m1 m2 by L square. So now equating these two, okay. Now simplify this, taking this one to here, and this is now here. I am taking G m and take L square outside. Remaining is now 1 by 9 minus 1 by 16. See carefully once. And I'm taking this part to right side. It is 2 times G m square by L square. So L square gets cancelled. G small m gets cancelled. G small m gets cancelled. Remaining is now capital M 16 minus 9, 7. 7 by 9 into 16. 9 into 16 is how much? 144, right? That is equal to m. That means small m is now 7m by 288. Okay. So answer is now 7. Okay. So here what we have taken, net force on these two is the same. Okay. It is not net force is 0. It is not net force 0 because on this net force is not 0. Okay. That's why what we are taking here, net force on both must be same. Right. But actually I think here I have taken 282. It is not 282 in the question. It is 288. Okay. Right. See next one. Four particles, each of mass capital and equidistant from each other, move along a circle of radius r under the action of their mutual gravitational attraction. The speed of each particle is. This question asked in mains 2014. It is a very simple question. Earlier we have solved for 3-point masses. Yes or no? Now only changes it is now 4-point masses. See how we solve it. When you are taking 4-point masses, and those 4 points will be on one square, and whose corners are on the circle. This is one square. Masses m, same masses. If you focus one mass, force acting on that. Focus any one mass, forces acting on that. Attraction like this. Attraction like this. And attraction like this along the diagonal. So net value how much means G m square. If side length is A, G m square by A. Since angle is 90, it is now root 2. Okay, resultant of these two. And that will be along this third one plus G m square by. Now this length of diagonal is root 2A. It becomes 2A square. This is net force. That net force equal to mass into acceleration. Acceleration is v square by r. Where r value is now a by root 2. Okay. R value is a by root 2. Then see what we get. 1m gets cancelled. Okay, in the place of this it right now it is a by root 2. Okay, a by root 2. Then see what we get. Gm by a square. Sorry, gm by a. 1a gets cancelled. Remaining is now 1 plus. It is 1 by 2 root 2. Check once. Root 2. We are having a by root 2. So I have taken root 2 here. Cancel 1 by 2 root 2. So gm by a 1 plus 1 by 2 root 2. That is now velocity. Or v equal to gm by a. That is gm by a into 1 plus 1 by 2 root 2 whole power 1 by 2. Right? That is the final answer. Okay. See next one. Let's see the question given. If g is the acceleration due to gravity on the Earth's surface, the gain in the potential energy of an object of mass m raised from the surface of the Earth to a height equal to the radius of Earth is. So we are raising to a height equal to r. Then what is now gain in potential energy of the object? Right. This is the question asked in 1983 in for 1 mark. See how we are solving it. So taken to a height h equal to r. So what is now change in potential energy? Now see what we can say here. This is a initially on surface. Suppose mass capital M, this is small m. So initially potential energy initial. So when you are taking one point outside, then we can assume entire mass of the sphere at its center. Okay. Then separation equal to r. Then potential energy equal to minus g m1 m2 by separation is r. Okay. If you are taking to a height h, then final value will be minus g m1 m2 by r plus h. Okay. Now see what is delta u. Delta u equal to final value minus initial value. Here final value is more because of the negative sign. Okay. Therefore final value minus initial value. I am taking g m m outside. Remaining is now 1 by r minus 1 by r plus h. Okay. Then see what we get here. G m m r plus h minus r, it is h. Okay. By r into r plus h. Right. Now what I am doing here, multiplying and dividing with r. Okay. Then r into r square. That is equal to, in the place of g m by r square, I am writing here small g. So it becomes now mg h or mgr into mgr into 1 by 1 plus h by r. Wait. Here I have, this is mgh, okay, not r. This is h, okay. That is mgh into 1 plus h by r. Means this is mgh by 1 plus h by r. So we can take into that form. This is now delta u. Okay. Now in this you have to take h value r. H value r means this becomes how much? 1. So mgr by 2. That is mgr by 2. That is now increase in the potential energy. Okay. So directly taking the expression for potential energy for 2 point masses. Initially separation equal to r, finally r plus h. Then delta u directly calculated. Right. So answer is first one.